The early pioneers were faced with these challenges of various problems toward the end of the 19th century, one of them being the discrete emission of light from atoms. And they wanted a mechanistic account of that, and it didn't work.
Keep watching to learn more.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we'll be looking at determinism and free will. With me is Dr. Ruth Kastner, who is a philosopher, a member of the Foundations of Physics group at the University of Maryland, College Park. She is the author of The Transactional Interpretation of Quantum Mechanics, The Reality of Possibility, as well as Understanding Our Unseen World, Solving Quantum Riddles, and Adventures in Quantumland, Exploring Our Unseen Reality. Welcome, Ruth.
Thank you. It's great to be here.
As I understand it, the basic idea behind determinism is very simple. It's that every event has a cause.
Right. And there's a single unique cause for every event that happens, and they're tied together in that way.
A single cause, because it would seem to me, Aristotle, I think, pointed out that every event has at least four different causes.
He meant, yes, he had different understandings of the different type of causes that you could have. But yes, so you're right. There are different notions of causation that you could look at. That's true. Yes.
And when I was in graduate school, I did have a philosopher as my dissertation chairman who told me that the whole notion of causality is considered very problematic.
Yes, it is. Yes, it is indeed. Different definitions and efforts to try to track it down by looking at the world around you, which, of course, as David Hume pointed out, you have trouble doing. So, yes.
I once had an argument with a skeptic of parapsychology. He said that parapsychology obviously is a pseudoscience because it violates the law of causality. And I responded to him by saying, I don't think that's a scientific law.
Well, yeah, it's kind of an assumption that people make. It's one of the ground rules that is not really all that well established. Bertrand Russell was critical of the idea, and it's more of a conceptual kind of pattern that we think we see in the world, but it's hard to find. It really is hard to find.
I mean, in classical physics, Newtonian physics, the idea is like billiard balls. One particle knocks against another one, and it moves accordingly. Right,
and that's kind of the picture I was thinking about when I talked about a unique cause for an event. In that case, the sort of mechanistic picture where you've got your billiard balls, and you've got a specific ball begins to move because it was hit by another ball, and so on.
Yeah.
And there are a lot of systems that seem to behave that way. Yes.
But, of course, Aristotle, thousands of years ago was looking at something different than that when he talked about...
He was. Yeah, I mean, well, of course, the notion of cause that he worked with that is not part of standard science, modern science at all, is the notion of final cause, which was an idea. He would say things like a rock falls because it's getting to it's proceeding to its natural place. So it's sort of a purposeful idea, which isn't, part of modern science.
In today, that idea would be called teleological, and it is ruled out generally.
Or it's assumed to be not a scientific notion.
Though I have to say, in my years in graduate school, one of my other advisors was a professor of management science. And he said, in management science, we have goals, we have purpose, we have teleology. It's not a problem.
And that's why things happen, because we make them happen to achieve those goals.
Yeah, I mean, every time you get in your car and drive somewhere, you have a destination in mind. And that would be like almost equivalent, I think, to Aristotle's final cause.
Yes, there was intent there. There's a purpose to be served, and that's why your behavior came about, because you chose it. And so on.
But in quantum physics, we have a notion of events for which there is no identifiable cause.
Right. We have that indeterminism. We have what Einstein called playing dice. Yeah. We have what people sometimes talk about as randomness. And what we have is a situation where, given an initial setup of preparation, however you want to set up your experiment, when we're working with these very small quantum systems for an identical preparation, and what we would say it's prepared in the same state, it can end up at different places. It can end up with different outcomes. And that theory doesn't give us any cause, no mechanistic, deterministic cause for why our system ends up in one place as opposed to another. All we have are these probabilities.
So some people in the world of physics postulate hidden variables in order to introduce causality at that point.
Exactly, right. They're missing. They feel as though there should be an explanation for some kind of a mechanistic causal explanation for why their system ended up in one outcome or the other.
I mean, for example, as I understand it, if you have a Geiger counter that is counting particles that are being emitted from a radioactive substance, we have no way of knowing when any particular particle will be emitted.
That's correct. It's indeterministic. It will give you probabilities that for each time index, that particle will decay. Yeah. But that's all you have, a probability that it will decay at that time.
But the actual moment of decay, it may, over many such decays, will conform to the probabilistic equation.
Exactly.
But no single instance will.
That's correct. I mean, no single instance will... you won't be able to point to any reason why that instance happened, why that decay happened at that time and not some other time.
So in my early years, when I studied with Arthur Young, who was as I mentioned, my mentor, the founder of the Institute for the Study of Consciousness in Berkeley back in those years where I was fortunate to live for a while, also the inventor of the Bell helicopter, he maintained, as many other people I think have maintained, that quantum uncertainty is on the outside what free will feels like on the inside.
Well, it could be. I mean, certainly if you only have the classical deterministic laws, then it seems as though all our actions are determined. And it's hard to reconcile that with free will. On the other hand, if you have quantum theory as a physical law of the way things work in the world, and these microscopic things are behaving in this indeterministic way, then that seems like it's at least an opening for genuine freedom of choice.
Now, I did an interview with another philosopher who said, no, you can't generate free will because quantum processes are random, and a random process doesn't exhibit free will. It follows the laws of randomness. It's unpredictable, and ideally free will would also be unpredictable, but that doesn't mean they're equivalent.
Yeah, well, the idea of randomness is, there's a subtle issue here because you can have an indeterministic law in the sense that, It does not follow that causal chain like we've seen with a billiard table or something. Yeah. But that doesn't, it's going a step farther to impose on that the idea of total randomness. Mm. All we really know is it's underdetermined. The what will happen at which outcome you'll get is underdetermined by the theory. The theory doesn't actually say that it's random in the sense of that there could be no intent or no choice. So that's something that people are used to imposing on an indeterministic law, the concept of randomness, but it has all these connotations of meaninglessness and no entry point for any kind of a choice. And that's not a necessary conclusion. In other words, we don't have to say that because we have an indeterministic law that the processes are random.
Oh, I assumed that they correspond to mathematical tests of randomness.
Well, the term random is in a mathematical context means purely indeterministic. And what I'm concerned about is this idea of randomness as having a connotation of that you could not choose in any particular instance. The subtlety here is that there's an idea of the principle of sufficient reason. Okay, so suppose in order to have anything happen, there had to be some sort of additional impetus that isn't part of this law. Okay, it's outside it. Then the process would appear to be random or what's thought of as random, but nevertheless there would be some impetus that precipitated one result in order to have that result occur. And it doesn't necessarily have to violate the statistical law. So there's a little, it's a subtle point that a lot of people think that in order to conform to a law, a statistical law, that there can be no additional factor involved in precipitating one outcome over another. But in fact, that's not strictly true. It's not strictly true. You don't have to violate a statistical law in order to have some other element that's outside the theory to trigger a particular instance. In fact, there's a whole article written about this by Randolph Clark, that addresses this point, this subtle point of, I think it's entitled, Can We Choose to Obey the Laws? So it's an examination of this idea of, suppose we have a statistical law that is truly indeterministic. Can people's behavior still conform to this on a large scale so that you never see any violation of the law, but yet in any given instance, they're actually choosing. And it is consistent. You can do that, in fact. Yeah.
Which is what my mentor, Arthur Young, proposed is in fact happening. He would have said, well, we live in a deterministic world on the macro level, but at the quantum level, it's indeterministic. That allows for free will. So we can have both determinism and free will, in that sense.
Right. And of course, in order to have your will have any effect at all, you have to be able to do things. Yeah. It's meaningless to say, well, I can choose to go have a cup of coffee if you then can't carry it out because there's total chaos in the world. Right. So it has to, at the macroscopic level, it does have to converge to a kind of an effective determinism at the macroscopic level.
It's required. Right. Otherwise, every time you get into your car and try to start the engine, you're not certain whether the engine will start.
Right. Of course. And from hundreds of years of study, we already know that at the classical macroscopic level, we have this apparent determinism. Yeah. So it's a surprise that when you go to this micro level, then you find these strange, processes.
So there were philosophers prior to the 20th century and quantum physics that were strict determinists, like Spinoza, for example. And his philosophy seems strange to me because he seemed to be suggesting that in order to achieve spiritual freedom, all we have to do is acknowledge that we have no freedom and that everything we do is determined. And ultimately, I think he meant by the will of God.
Yes, of course, before quantum theory, that was their only choice. In a way, they had no choice because they really thought that the world was deterministic. And I think of that as kind of a Stoic view. And it's a little hard to, I would I'd have a hard time personally finding anything enlightening about the idea that all of my choices and actions are chosen in a sense not by me but by some larger order or by God or whatever. But it's a kind of an academic point since we now have reason to think that that's not the case. But that was a tough situation where they had a lot of what I think are kind of convoluted arguments to try to find some people to find room for free will. Although in Spinoza's case, he went the other way, other route, and said, "Okay, I don't have free will." And
there is in philosophy two viewpoints known as compatibilism and incompatibilism regarding the relationship between free will and determinism.
Compatibilism is the idea that if the world is deterministic, or if we have some sort of a block world where all events are already spoken for and they're already out there from the beginning of time to the end of time, that's the idea of trying to retain the notion that we have some kind of meaningful free will or freedom of choice in that situation. That's compatibilism. And then incompatibilism is the opposite view, that if we do really have determinism or we have a block world where all events are determinate, are out there, that in fact we cannot have chosen otherwise. And so then what happens is never really up to us in a sense. So those are the two competing viewpoints.
Now, I have heard it articulated that, and I think this would be sort of a compatibilist point of view, that if I make a decision and nobody is coercing me to choose differently, so that the only deterministic factors are my own preferences, then that could be considered an act of free will.
Well, and that's a way that a lot of compatibilists want to define the term. But if you do take seriously the claim that all physical laws are deterministic or that all the events are already there, then it's kind of self-refuting, because they've already said everything I do is happening because of some law or some events that happened before I was born or because of some events that are already there. And so there's no room there for me to have actually chosen anything by their own claims. Yeah.
So in a totally deterministic world, if we're having this conversation, we don't have any choice but to say what we say.
Right. There are deterministic laws in play, so the claim is, and those laws are just unfolding what was basically set up incontrovertibly by what events that were in place before we were even born. And so in a sense then, we're just like marionettes on a string. Right? We're marionettes, and it's like a marionette saying, "Hi, I'm choosing to do something." And it's your strings so it's just not really. But
I gather what you're saying is that anybody familiar with quantum physics can no longer be a strict determinist.
Well, actually, they can have certain models where they want to put in hidden variables. So there are deterministic models that are efforts to take quantum theory and give an account of why each measurement outcome happens. And those are actually deterministic theories, like the Bohmian theory, for instance.
Okay.
Yeah.
Which relies on hidden variables.
Right.
Which is kind of a trick.
Well, they're adding something to the theory to get what they'd like to see, Which
happens in physics quite a bit.
It does. It does, yeah. But I mean, the point is that basically given quantum theory, even though the theory in itself, in its most pared down, purest form, if you will, seems indeterministic, you can add things to it and sort of tinker with it a little and end up with a deterministic model of quantum theory, so that you're eliminating the indeterminacy.
But I suppose it's fair to say at least the great bulk of theoretical physicists don't take that route.
Yeah, I mean, it's always hard to know, actually. They're constantly doing these little surveys, what's your current preferred interpretation? And people sometimes change their mind. And so I'm not even sure I would know what to say, as far as the majority view. But there's certainly a large component of physicists who do take it as indeterministic.
Well, and I understand, though, that a very popular interpretation of quantum physics is the many worlds. Everett Everett and Wheeler's Many
and
Worlds.
Graham, I think. Yeah,
Graham
Wheeler.
That would be, I think, in your view, a deterministic model that it just means that every time a quantum event occurs, every possible event also occurs in some invisible realm.
Yeah, I mean, that's interesting. Is that a deterministic model or not? I mean, it takes the sort of deterministic evolution of the quantum state as the only evolution. So in that sense, it's deterministic, but yet it also has all the outcomes occurring. And then, there's versions of each observer, say, in seeing each of these different outcomes.
That theory has always puzzled me, because if you look at the quantum wave function, it suggests there could be millions of potential outcomes for any single event of an electron or a photon being emitted from an atom.
That's right. I mean, you're getting into some very big numbers, possibly infinities.
Yeah.
You're having, and they're splitting who knows how frequently.
Yep.
So it's a very extravagant kind of ontology. The other problem I feel with that interpretation is that it kind of removes the idea of probabilities, in a sense that you can't even define a probability if you can't say, you have no way of saying which outcome occurred, because they all occur. So if all outcomes occur, then how is it meaningful to say that each outcome has a certain probability? Mm-hmm. So it's even hard to apply the usual quantum probability law to that approach, because if all outcomes happen, then what's the meaning of the probability that it will happen? Mm-hmm. It's the probability that you will be observing that outcome. But who are you? Yeah. Which you are you? Yeah. So it gets into some areas that become ill-defined.
But it would imply that there might be zillions of versions of each individual.
Yes.
Existing in some other parallel universe somewhere.
Right. Mm-hmm. Yeah.
Which it does seem to be kind of metaphysically heavy. It has an awful lot of assumptions.
Well, yeah, I think they would say, well, we have very few assumptions, but the ontology is huge. We're going to assume that there's no such thing as measurement, or that there's no projection, there's no collapse. So they want to eliminate any additional assumptions along those lines, but yet the ontology becomes just really very, very burdensome, I think.
Well, and I have heard that the many worlds interpretation is gaining in popularity because people find it as something of a refuge, and that they don't have to introduce consciousness as an alternative way of collapsing the wave function.
Well, I think that the whole notion of collapse in the usual way of looking at the theory is problematic. Mm-hmm. So people want to not have to think about why we get one outcome. Mm-hmm. And then if they can say, well, we don't just get one outcome, then that takes that problem away. But it does have other problems, and it has, you have to kind of apply a sort of a pragmatic kind of decoherence approach to that has certain problems, that it's a bit circular, where people try to say that they can get our usual classical world of experience out of it. But in order to do that, they kind of have to smuggle in certain classical concepts at the very beginning in order to get the kind of splitting that they want.
Well, I gather that among science fiction writers, it's a very attractive theory.
Yes. I mean, it's great for science fiction stories. Yeah. No argument there, right? Mm-hmm. I mean, and it's fun to think about parallel realities. Yeah.
Now, your preferred interpretation, the relativistic transactional interpretation of quantum mechanics, does allow for free will.
Well, yes, in principle it does, because it does have genuine indeterminism, and it does have a real form of collapse or reduction of the quantum state, is what I like to, the term collapse is kind of a problematic one, but it allows that one outcome really does become actualized in the macroscopic world, but it's genuinely indeterministic which one will happen. And so in that sense, it allows for free will to enter. Mm-hmm. Although that's not a formal part of my interpretation, but it does allow for that.
This interpretation of quantum physics, in fact, every interpretation of quantum physics really has nothing particular to say about consciousness.
Not really, no. I mean, it's a physical theory, meaning that it's a theory that was arrived at to to describe things that were puzzling about the world and to try to understand how they worked at a deeper level. And it's not to say that, that we're adopting physicalism or something like that, but it's simply a theory of mathematical physics that uses mathematics to describe regularities that we see and that comes up with a theoretical structure to help you predict things that you're going to find.
Yeah. Now, my friend Saul-Paul, who's been a guest on this channel many times, would take it a step further. He would say that all the laws of the physical world, of quantum physics, actually are descriptions of consciousness because that's all that we ever have.
Well, yeah, people have found quantum theory to be evocative of the notion of consciousness. To some extent, that came about because the early quantum pioneers couldn't find any theoretical reason for finding outcomes, for finding specific outcomes when you had these superpositions and, many possible outcomes, but you could never account for why we only experienced one. And so the only response they could find was to say it's consciousness, that consciousness is what allows me to experience only one outcome. Now, I've argued that's because they were missing part of the physics in the direct action theory that allows you to really say within the theory why one outcome does occur. So that's kind of an account within the theory of why we get our outcomes, but it doesn't preclude the idea of perception and of conscious perception. So that does come in, but then it becomes kind of free to be explored on its own terms rather than being what I call kind of a Band-Aid for the measurement problem. Consciousness has been historically brought in as sort of a Band-Aid for why the cat is not both alive and dead. Well, there's a conscious observer that collapsed it. But that's a very ill-defined account in terms of where does the consciousness come in and why and what kind of system counts as a conscious system and so on.
Now, you mentioned the direct action theory.
Yes, and we talked about that elsewhere.
We did, but let's define it again.
Of course. So the transactional interpretation is based on a different kind of theory of the way fields interact. And it's a theory in which emitters and absorbers participate equally in order for there to be any transfer of radiation or a photon or something like that. So that's called the direct action or absorber theory of radiation.
Why is it called direct action when it seems as if you've got two different entities, the emitter and the absorber, as you say, shaking hands, coming together? It would direct.
It's a funny word that historically was used to mean a kind of action at a distance theory. That's what the term direct action was, kind of a term for action at a distance, which meant it was non-local. So the way the fields behave is called non-local because the fields don't need to have a mediation by a kind of mechanical system that is the usual traditional way of modeling fields. It's actually like a bucket brigade. And the so-called direct action theory doesn't use this bucket brigade. It's a non-local communication between different charges.
Well, the whole question of non-locality is fascinating, and mechanism, because we are conditioned to think mechanistically.
Yes, we are.
And we're educated to think that way. I suppose it's fair to say Newtonian physics is almost entirely mechanistic.
Right, the clockwork universe.
Yeah. And people I know when I was an undergraduate and even early years as a graduate student, I had to work hard to not try to explain parapsychological phenomena within a mechanistic framework. I'm pretty convinced at this point that you can't. That mechanistic frameworks will always break down when it comes to the phenomena of parapsychology.
Well, it broke down with respect to atomic behavior. I mean, that's why with the early pioneers were faced with these challenges of various problems toward the end of the 19th century, one of them being the discrete emission of light from atoms. And they wanted a mechanistic account of that. And it didn't work. So that's why we have quantum theory. And of course, with quantum theory, there are still mechanistic ways of trying to approach it. Because as you say, we've been marinated in, mechanistic concepts, and it's very hard. That's sort of our ordinary common sense existence. And it's very counterintuitive to think that maybe at the very subtle level of these quantum systems that in fact things are not mechanistic. Mm-hmm. So it's hard to get used to that idea.
Well, and of course, mechanistic is really another way of saying determinant.
Yes, right, mm-hmm. right, yeah, deterministic and processes that are mediated very causally, where you can point at any given point in space and time what exactly is going on. Everything's very localized. Again, like the bucket brigade picture.
Yeah. But if we allow for free will, which, as you point out, quantum physics at least allows for the possibility of free will, that if free will exists in the universe somewhere, then the notion of teleology or purpose is also introduced, wouldn't you say?
I think so. I mean, you can't really eliminate it. I know that a lot of theoreticians, they would kind of break out in hives at the thought of, having that enter into modern science. And you have to be very careful. You have to be very careful about that. But certainly once you have room for intent or volition, then clearly those are teleological notions. Mm-hmm. So, there you have it.
Yeah. I mean, in a way, I think the big battleground for this discussion has to do with evolution. And people who mm-hmm. say evolution is purely the result of, random processes and survival of the fittest, and other people who say, no, there seems to be an entelechy or a teleology, or, the evolution shows that things are getting more and more complex.
Yes, and of course, I'm not at all an evolutionary biologist, so, I have no particular expertise in that area, but clearly we do have kind of a culture clash, don't we? I mean, mm-hmm. we've got this laudable drive to be rigorous and to not get lost in metaphysical flights of fancy, which is part of that sort of ethos of mechanism, and it's a laudable goal to be rigorous. But on the other hand, it becomes a box that did slow down the development of quantum theory in the first place, when people were really hampered by that to an extent where they were not imaginative. They mm-hmm. couldn't come up with new ways of thinking and new ways to solve problems. So, the door is open to consider that there may be intent, there may be volition at some level.
Mm-hmm. Well, I have heard people complain that we're not making any real progress in physics, that, we're still sort of stuck with the quantum theory that was developed nearly 100 years ago. How do you view that?
Well, we're not making progress if we keep working with, I think, this sort of unilateral picture of the way fields operate, mm-hmm. and the failure to really solve the measurement problem, which is often taken as, it's gotten to the point where it's the failure to solve the measurement problem, by which I mean account for measurement results mm-hmm. in a theory, in a rigorous way, mm-hmm. has become almost an article of faith that's something that you should learn to live with, and it's the way it should be. That it's appropriate to fail to solve the measurement problem, mm-hmm. and it's sort of elevating failure to a putative success, that this is right thinking, and that it's a lesson of some sort. But I think that we've stalled out there. We do have a better way to proceed, and some of my work is an effort to try to point out that mm-hmm. Now the model I propose may not be right, may be wrong, but at least consider it. It mm-hmm. gives you some reason to have measurement outcomes and to have your quantum probability rule. And so it's a possible way to make progress. And so, there's some ideas out there that I think could be stepping stones to more progress if people mm-hmm. there's a culture of there's a culture that wants to forestall that, but I think, we can make progress.
You're referring to an attitude that I have heard physicists express right here on this channel when they begin questioning at the foundational level of physics. They're told, the calculations work, just do the calculations and don't bother yourself with the other details.
Right, the shut up and calculate, idea. And that's just kind of an abdication of the scientific mission, really. And it's instrumentalism. I mean, it's a move to say that theories can never be anything more than instruction manuals or booklets for predicting what we will experience. And there's almost an approach of saying that this is the way you should approach it, that this is a normative posture, and this is the way you should be working with physical theory. And in fact, they just haven't made use of all the tools that are available, and they have certain conceptual restrictions, like the idea of actualism, that the only real things are actual things. And so, if we have a little more imagination, we don't have to retreat into instrumentalism in that way.
Right. The subtitle of your first book, The Reality of Possibility, is a very different view than actualism.
Right. And I mean, my suggestion is that quantum theory simply is giving us a structure of the world that we weren't expecting. And it's a subtle structure beyond the actual manifest world that is that of possibility. And it's not a really new idea. Heisenberg was proposing this, a long time ago. He didn't follow it up, the idea of potentiality. So there's that idea out there that if we let go of the idea that physical theories can only describe actual phenomenal manifest things, that the theory may be telling us something very interesting about reality.
It would seem to me, if I'm struggling to make an important decision in my life, which I have from time to time, as every person has, that's very much analogous to this physical situation you describe of moving from possibility to actuality in a quantum system.
Right. Yes. The deliberation over possibilities and kind of trying to keep your options open and maybe suspend making that choice until you feel like you're happy with or there are good reasons for choosing something. And all of that is, I think, made much more meaningful if we take our theory of fundamental reality as describing that kind of situation, rather than just the idea that all of my choices are illusory because laws dictate whatever it is going to happen is just going to happen.
I've shared with my viewers and many other occasions one of the most major decisions in my life, a decision as I recall, that goes back to 1972, but is ultimately responsible for you and I being here together in the video studio now. I struggled over that decision for months. And then after months of anguish, I had this feeling that the answer was going to come to me in a dream. And that night I had a very specific dream that led me to doing what I'm doing now, which is interviewing.
Interesting. Yeah, I mean, the idea of having intuition, again, this is a very subjective, internal kind of process, and it's not part of the traditional physical world. It's not part of the empirical, corroborated world. And yet, obviously, it's very real. And I guess what I find intriguing about the idea of quantum theory as being about real possibilities is that one of our best physical theories is pointing to a deeper level of reality that we have internal corroboration of that. In other words, that makes a kind of a unifying influence on the inner and outer aspects of experience, I think. And
today, I mean, since for the last century, almost simultaneous with the development of quantum physics, we had the development of depth psychology. Freud and Jung, who describe in great detail what they call the unconscious or the subconscious mind. It seems in many ways analogous to they even use the same metaphor of the iceberg.
Interesting. Well, it could be two sides of the coin. We have the sort of the external reality of our five senses, and then there's an internal reality. So that this could be the coin, that the classical physics, the traditional mechanistic approach, is only describing that one side of the coin, but there's this other side of the coin that's very important.
So when you talk about the reality of possibility, and you're referring ultimately to the equations of quantum physics, it might apply equally well to the descriptions of the subconscious mind.
Now, it might. I mean, of course, what I treat formally in my model is only that it's quantified by quantum theory as applied to specific systems that we've already talked about in physics, such as the hydrogen atom, electron. So they're very specific systems, but by extension, there's nothing to preclude the idea that at these subtler levels, that we similarly have abstract possibilities that are intuitively
I understand that as a rigorous philosopher, you're not yet prepared to.
Well, I mean, my model doesn't speak to that.
Yeah.
So, but it's certainly, there's no contradiction. I mean, someone could say, well, if quantum theory and if the relativistic levels of quantum physics are pointing to all of this activity that's beneath the surface, then there's no reason to shut off the idea of our subjective internal intuitions and so on. In fact, as I said, I think in one of our past discussions, if our sort of macroscopic phenomenal world is embedded in some higher reality, some higher dimensional reality, we're kind of like that flatland square that can have internal perceptions that are really because he is immersed in some higher, space land or whatever, and can be contacted by these other elements, even though at the level of flatland, that would not be empirically valid, right? So strictly speaking, his fellow flatlanders would say, no, look, you had some gut level feeling. Don't tell me you're doing physics here, but in fact, if physics is telling us that he's in a higher dimensional reality, then his experiences may be perfectly compatible with that physical theory.
Well, Ruth Kastner, once again, a fascinating discussion. Thank you so much for being with me.
It's been fun. Thank you.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.